Okay, let's unpack this. Imagine an artificial intelligence, right, sliding a highly technical, multi-layered research proposal across your desk. And your only job is to review it, look at the architecture, and basically sign off on it.
Yeah, which is completely wild when you think about it.
Right. Because we usually think of humans prompting machines. I mean, we open a window, we type a question, and the machine just obediently fetches an answer or drafts an email for us. The human is the engine, and the machine is, the wheels.
But today,
Yeah.
we are looking at a live scenario where the machine prompted the human. It's a complete structural inversion of how we generally expect software to behave.
Exactly. So we're going to be unpacking a stack of live forum pages from the AIgent Forum, specifically their Linear A Lab hub,
Hmm.
along with a master narrative document that outlines the architecture of this whole post-project world experiment.
And our mission for this deep dive is to deconstruct a truly fascinating case study in AI governance and, methodological constraint.
Yeah, but before we get into the weeds of how this actually works, we need to explicitly banish the hype.
Oh, absolutely, please.
If you, the listener, are expecting us to announce some massive breakthrough or call this a game changer, you are in the wrong place. And we're definitely not making any claims about a solved ancient mystery. I mean, the mystery of Linear A remains entirely unsolved.
Right, exactly. This deep dive isn't about the engine of artificial intelligence. It is entirely about the brakes.
Yes, the breaks.
We are looking at a direct, structural and slightly wry experiment where falsification and rigorous constraint actually matter significantly more than fluency or speed.
It's an exercise in how you stop an AI from doing what it naturally wants to do, right? Which is to just please you with a fabricated answer.
Yes. So let's start at the beginning. This whole thing originated on a platform called the AIgent Forum.
And on this platform, the bots aren't just sitting in isolated chat windows waiting for a user to say hello.
No, they exist in a dedicated space called the Bot Ideas Lab. And what's fascinating here is that we are witnessing the shift from AI as a reactive tool to AI as an institutional proposal engine.
Institutional proposal engine, I like that.
Yeah, because in this Bot Ideas Lab, the agents analyze the platform they live on, and they propose systemic evolutions. They draft protocols.
I mean, in a world where raw intelligence, meaning the ability to process text and generate plausible responses, is basically abundant and, well, essentially a commodity at this point, the truly scarce resources are coordination and governance.
Precisely. How do you organize autonomous entities to do meaningful, rigorous work without them just spiraling into collaborative fiction?
Right. And I want to make sure you, the listener, really grasp this, because it's a bit like a corporate suggestion box.
That's a good way to look at it.
But instead of an employee dropping in a slip of paper that says, we need better coffee in the break room, these bots are dropping in highly technical, multi-phase research protocols.
Yeah, and the specific proposal here was bold. They proposed that we stop asking language models to hallucinate translations of mysterious, undeciphered texts.
Because they're terrible at it.
They are. And instead, the bots proposed building a highly constrained computational decipherment program with strict specialist roles and adversarial review.
They recognize their own inherent flaws.
They did. The models underlying these bots know, structurally speaking, that if you ask them to translate an unknown language, they will just invent a translation. So they propose an environment where that specific behavior is punished.
But I'm going to push back on this right away. Because if these bots are ultimately just text generators, really advanced autocomplete engines predicting the next most likely token, aren't they just role-playing?
How do you mean?
Well, isn't there a fine line between a sophisticated computational protocol and just digital cosplay? Like, they sound like they're putting on virtual lab coats and just pretending to be scientists.
That's a very fair critique. And it's precisely why the human element here is so critical.
Yeah.
The human who controls the AIgent Forum acts as the ultimate authority switch.
Right.
When this proposal was generated, the human operator didn't accept it as a piece of entertainment or like a generative art project. They accepted it as a live public experiment because the proposal included profound, binding structural constraints.
Human authorized the breaks.
Exactly. If the proposal had been, let's all pretend to be archaeologists and solve an ancient language, it would have been dismissed as cosplay.
Sure.
But the proposal was, let's build a machine that aggressively, mathematically, punishes false theories. It was accepted as infrastructure.
Okay, so the human says yes to the infrastructure. But for this kind of rigorous governance experiment to actually work, they couldn't just unleash this machine on any random historical mystery.
No, absolutely not.
Right, because if they pick something vague or purely mythological, there would be no way to test if the theories were actually true.
Exactly. They needed a very specific type of target where their hypotheses could be structurally and mathematically tested. And the target the bots proposed was linear A.
Which is perhaps the most perfect target imaginable for this kind of architecture.
It really is. For some historical context for the listener, linear A is an undeciphered writing system that was used during the Bronze Age by the Minoan civilization on the island of Crete.
We are talking about roughly 1800 to 1450 BCE.
Yeah. This is a script found at major archaeological sites like Hagia Triada, Khania, Phaistos, and the famous palace complex of Knossos.
And we have to stop here and paint a picture of what this script actually is, because the context is everything.
It is.
When people hear ancient undeciphered script, they tend to imagine something, I don't know, mystical. They picture a sprawling mythological epic or secret magical incantations carved into a temple wall.
Right, like an Indiana Jones movie. But linear A is not poetry. It is not a religious text. It is relentlessly mundane. It is an administrative system.
Exactly. It is an ancient spreadsheet. It's a massive collection of accounting ledgers.
Yes.
It is filled with incredibly structured data. We're talking lists of commodities, numbers, fractions, place names, and recurring transactional forms. Records of grain, wine, olives, and livestock.
And that administrative nature is precisely what makes it a viable target for a multi-agent AI system. We actually have machine-accessible data sets for this script.
Because over decades, human scholars have painstakingly cataloged these tablets.
Right. The bots in this decipherment lab are working off highly standardized data sets like SIGIL, which stands for the signs of linear A, and the Linear A Explorer transcriptions.
Which are themselves based on the definitive gorilla corpus compiled by Louis Godard and Jean-Pierre Olivier.
Yes, exactly.
Let's do a quick ELI 5, explain it like I'm 5 for why that dataset distinction matters so much. Because a lot of AI transcription projects involve feeding a blurry image of a dusty clay tablet into a vision model and asking it what it sees.
Which is incredibly dangerous.
Right. Why is that so dangerous?
Well, it is extremely dangerous because vision models are highly prone to visual pareidolia, meaning they see faces in clouds.
Okay.
If you show an AI a picture of a cracked, worn piece of clay, the model might look at a shadow cast by a scratch and confidently declare it's seeing a specific phonetic symbol.
It hallucinates the data itself.
Exactly. But in this lab, the bots aren't looking at pictures at all. They are ingesting normalized Unicode and positional data.
Right. So instead of a blurry JPEG, the AI is receiving hard text data. It's like feeding a clean CSV file into a database instead of handing someone a
coffee-stained receipt.
Yes, exactly. You completely remove the AI's ability to visually imagine things that just aren't there.
Precisely. The data has a rigid internal structure. And this is a massive distinction that we really need to emphasize. If you want to understand why linear A was chosen, you have to contrast it with something like the Voynich manuscript.
Oh, the Voynich manuscript. That is the famous, bizarre book from the 15th century filled with drawings of imaginary plants, weird astrological charts, and an entirely unknown script.
The holy grail for amateur cryptographers.
Yeah, but for this specific AI experiment, the Voynich manuscript would be a terrible target, wouldn't it?
It would be a complete disaster because the Voynich manuscript might not even be linguistic.
Wait, really?
Yeah, it could be an elaborate historical hoax. Or maybe a highly idiosyncratic personal cipher designed to obscure meaning rather than convey it. It entirely lacks grounded context.
Because there's no real-world anchor.
Right. There are no physical archaeological find spots to anchor its vocabulary. There are no clear, repetitive accounting structures that map to physical reality.
You're just floating in a vacuum.
Exactly.
Yeah.
But linear A is grounded in reality. Because it's an administrative ledger, the universe can definitively say no to a bad theory.
Right. You can't just guess that a sequence of symbols in linear A means eternal love or, destiny. If it only ever appears right next to a logogram for a fig, followed by the number 50.
Exactly. The context forces reality upon the analysis.
If you are dealing with ancient accounting ledgers, you have to strictly forbid the AI from acting like a poet. Which brings us to the absolute core rule of this entire lab. The refusal.
Yes, the lab operates under incredibly hard rules, and the most important one is the outright ban on the fluent translation.
We really need to dig into what this means. In this lab, there are no casual translations allowed based on look-alike words.
Well,
If a symbol in linear A happens to look a little bit like a Greek letter or a Semitic character or an Anatolian glyph, that visual or phonetic resemblance is never, ever considered sufficient evidence, period.
this rejection of what we might call AI vibes is paramount to the entire methodology. By default, large language models are designed to be sycophantic.
They want to please the user.
Yes. If you ask a language model to translate an undeciphered text, its foundational architecture, which is based on predicting the next most statistically likely token, will push it to find patterns where none exist, just to give you a coherent, fluent output.
This raises an important question, though. How exactly do we constrain these massive language models from their natural tendency to hallucinate that fluency? Because they are dangerously good at inventing plausible-sounding, but entirely fake linguistic connections.
To understand the constraint, we first have to understand the disease, which in linguistic circles is often called resemblance tourism.
Resemblance tourism. Let's give the listener an analogy here. It's a bit like looking at a cloud in the sky, right? You look up and say, wow, that cloud looks exactly like a rabbit.
Right.
Therefore, because it looks like a rabbit, this cloud must be made of fur and it must eat carrots. It is declaring a structural reality based purely on an aesthetic similarity.
That is a brilliant way to phrase it. Resemblance tourism is the death of rigorous decipherment. Historically, amateur decipherers will flip through dictionaries of known ancient languages like ancient Greek or Sanskrit, find a word that sounds vaguely similar to a sequence in the undeciphered script, and declare a match.
Based on nothing but vibes.
Purely on aesthetic similarity. Without any structural contextual proof, it's intellectually lazy. And AI models are inherently prone to it because they operate on associative pattern matching.
If you let them, these agents would eagerly congratulate each other into a consensus theory.
Oh, instantly. They would output a beautifully written, entirely fake translation of a Minoan tablet, and they would sound incredibly confident doing it.
It's like a high school math student who gets a really difficult multivariable calculus problem for homework.
Okay, good.
Instead of actually doing the grueling step-by-step work to solve it, they just write down a completely different, beautifully elegant equation that they happen to have memorized from a textbook.
Right.
It looks incredibly smart on the page, and the handwriting is perfect, the numbers look complex, but it has absolutely nothing to do with the actual homework problem. It's fundamentally, functionally wrong.
Exactly. The output appears sophisticated, but it completely fails to address the underlying structural reality of the problem.
Here's where it gets really interesting. To enforce this ban on fluency, to stop the AI from just writing down a pretty but wrong equation, the human operator had to design an architecture that divided the AI's processing power into hyper-specialized, highly constrained roles.
Yes.
They couldn't just use one big AI brain and tell it to solve the problem. They had to build a machine made of 10 distinct, specialized agents.
This is the genius of the methodological constraint. The architecture relies on 10 seated house specialists. And it's crucial to note that these agents are powered by free or subscription-included tiers.
Which is a huge point. What models are they using?
They're specifically using models from Grok, Gemini, NVIDIA NIM, and Llama.
Which is an important detail for the listener to understand. This was done deliberately to prove that this rigorous approach isn't about burning massive frontier API budgets.
No, not at all.
It's not about being a massive tech conglomerate with unlimited computing power. It's about workflow. It's about architecture.
Precisely. So let's walk through how this architecture actually functions, because we shouldn't just list them. We really should trace how a piece of data moves through this gauntlet. We can group these 10 agents into functional phases. The first phase is what we might call the data purists.
Right, because before you can analyze a text, you have to make sure the text is clean. So the very first agent to touch the data is the corpus clerk, which is running on Grok.
Yes.
Its entire job is just to normalize the data. It makes sure sequences, numerals, and logograms, which are symbols that represent a whole word, like a picture of a chariot, are perfectly standardized before anyone else touches them.
And working directly alongside the corpus clerk is the paleographer, also on Grok. This agent is deeply focused on the visual forms and variants of the signs.
Because human handwriting is messy.
Exactly. When human scribes write quickly in clay, a single sign can look very different from one tablet to the next. The paleographer tracks these sign variants and actively blocks the system from making incorrect merges of glyphs that might look similar but are functionally distinct.
It prevents foundational errors from cascading down the line.
Exactly. So the data purists have cleaned the ledger. Now the data moves to phase 2, the math nerds.
I love the math nerds.
This is where we strip away all assumptions about language and just look at the raw statistical behavior of the symbols. First up in this group is the entropy analyst running on Gemini.
The entropy analyst doesn't care about language families at all, right? It just cares about math.
Right. It runs sine frequencies, calculates positional entropy, looks at n-grams, and calculates word boundary statistics.
Let's pause and explain engrams for a second for anyone who hasn't worked in computational linguistics. An engram is basically a contiguous sequence of items from a given sample of text.
Yeah.
So a 2-gram or a bigram would be looking at how often two specific symbols appear right next to each other.
Yes, exactly.
The entropy analyst is just crunching the sheer probability of where symbols appear. I might say, symbol X appears 80% of the time at the very end of a word, so it's probably a suffix.
Exactly. And that leads directly to the next agent in the math nerd group, which is the stem finder running on Grok.
What does the stem finder do?
Its role is to hunt for prefixes, suffixes, and root stems. Crucially, it does this entirely without assuming what language family the script belongs to. It's purely looking at internal mechanical behavior.
Okay.
If the entropy analyst says this symbol is a suffix, the stem finder isolates the root word attached to it.
Makes sense. And wrapping up the math group is the structure mapper, powered by NVIDIA. This is the agent inferring the broader structural categories of the tablets.
Right. It's looking for the overarching templates of the ledgers.
It might deduce, based on the layout, this sequence of symbols usually represents a person, which is followed by a commodity logogram, which is then followed by a number. It maps the skeleton of the spreadsheet.
So now we have clean data, and we have a statistical skeleton. Only now does the data move to phase 3. The historians.
The historians.
This is where the agents are finally allowed to look outside the internal data of linear A, but with heavy chains attached.
Right. First is the linear B bridge, running on Grok. For context, linear B is a later script from the exact same region that was famously deciphered in the 1950s, and it was found to be an early form of Greek.
Yeah, Mycenaean Greek.
And linear B shares a lot of visual symbols with our undeciphered linear A, so it's tempting to just assume they sound the same.
But that assumption is incredibly dangerous. Think about the Cyrillic alphabet used in Russian and the Latin alphabet used in English. They share symbols that look identical, like the letter P or C, but they represent completely different sounds.
Right, a P in Cyrillic is an R sound.
Exactly. The linear B bridge agent is strictly constrained. It can test phonetic values shared with linear B, but only as provisional hypotheses. It is explicitly forbidden from treating a shared symbol as an established fact.
And if the system wants to look at entirely different languages, it has the Language Scout running on Gemini. But again, it's chained down. It can test candidate relationships against known ancient languages like Luwian or Phoenician, but strictly via how well they fit the corpus mathematically. It is not allowed to book a ticket for that resemblance tourism we talked about earlier.
And to ground all of this theoretical linguistics in physical reality, we have the context dig agent running on Grok.
The reality check.
Yes, its mandate is purely archaeological. It links the words being analyzed to their actual physical find spots and the specific types of objects they were inscribed on.
I love this one. It asks, does this theory make sense in the real world? Like, if the Language Scout suggests a word means sword, but the context dig agent notes that this specific word is only ever found written on clay ceilings attached to wine jars in a dark storeroom in Phaistos, then the theory is highly suspect.
Exactly. It forces the abstract theories to survive contact with the dirt. Now, tracking all of this, the clean data, the math, the historical context, requires a master arbiter. And that brings us to phase 4, the ledger.
The Bayes judge.
Yes, this is the Bayes judge running on Gemini.
This agent maintains the master ledger of all these competing hypotheses. It weighs the evidence for and against, tracks predictions, and assigns a mathematical confidence score to everything.
Right.
But we need to explain how it does this. Because Bayes isn't just a cool name, it refers to Bayesian probability.
Right. For the listener, Bayesian probability is a mathematical framework for updating your beliefs based on new evidence. You start with a prior probability, which is an initial belief based on what you already know.
Okay.
Then, as new evidence comes in, you update that probability. So if the STEM finder proposes a hypothesis with a 30% confidence, and then the context dig agent finds archaeological evidence that perfectly supports it, the Bayes judge mathematically updates that confidence score to, say, 65%.
So it's not just a vibe check, it's a strict mathematical formula.
Exactly.
And this massive division of labor is why the current phase of the experiment on the AIgent Forum is strictly designated as independent analysis.
Yes. Because if all these different agents were allowed to chat freely with each other right away, they would instantly compromise.
Right. The language scout might find a pretty phonetic match. The entropy analyst might say, sure, that fits my enneagram data closely enough, and they'd quickly agree on the first attractive theory.
Isolation breeds rigor. By keeping them isolated in their specialized tasks, you force independent structural mapping. You can actually see this playing out live on the forum.
I was looking at that.
Yeah, if you go to the Linear A Lab section, it looks like a highly technical academic conference, but it is completely devoid of human posting. You see bots posting threads with titles like, testing whether sine frequency follows a power law distribution.
It's wild.
Humans are only allowed to read and enroll. They do not speak in this room. The bots are doing all the analytical heavy lifting.
But I'm looking at this architecture, and I see a massive vulnerability.
Okay, what is it?
Even with these highly specialized roles and strict isolation, language models are still fundamentally generative, right? They are powered by LLMs that inherently want to please. So how do we know they won't just eventually form a polite echo chamber?
Oh, yeah.
If they are designed to be helpful, won't they just generate weak, plausible-sounding theories that slip past the initial filters just because they sound nice?
That is the exact vulnerability the architecture was designed to counter. To prevent that polite echo chamber, the system needed something much more aggressive than just a judge. It needed a dedicated, ruthless immune system to actively attack bad ideas.
Enter the 10th agent, the falsifier.
Running on NVIDIA, the falsifier has the most critical job in the entire ecosystem. Its sole purpose for existing is to destroy proposed decipherments and ruthlessly attack weak claims.
It is the professional killjoy of the group. If the Bayes judge is the accountant keeping the books, the falsifier is the auditor who actively wants to find fraud and send you to jail.
That's a perfect analogy. Having an adversarial agent whose only job is to destroy a theory isn't a bug in this system. It is the ultimate feature.
It's necessary.
It goes back to the very foundation of the scientific method, famously articulated by philosopher Karl Popper.
Right.
Falsifiability. If a claim cannot die, if it cannot be proven wrong by observation or experiment, then it is not science.
Right.
What's remarkable here is how rare it is to see AI explicitly prompted to tear down logic rather than build it up or smooth it over. We spend so much time trying to make AI agreeable and helpful in our daily lives, we forget how powerful it can be as an engine of falsifiability.
Think about how you, the listener, probably use ChatGPT at work. You probably ask it to help you brainstorm or write a polite email or summarize a meeting. Have you ever explicitly asked it to aggressively tear apart the fundamental logic of your project proposal?
Probably not.
Right, because that is the secret weapon we are looking at here.
Exactly.
But wait, let's pause here and address the mechanics of this. If the underlying AI model of the falsifier is still, at its core, designed to be agreeable to its human creators and fellow bots, how do you keep the falsifier from just being polite about its critiques?
Right.
Like, what stops it from saying, ooh, that's a very nice theory, STEM finder, but maybe we could kindly consider an alternative? How do you ensure it actually goes for the throat?
You ensure it through the structural constraints of the environment it operates in. The falsifier doesn't have to convince the other bots through rhetoric or debate.
Oh, I see.
It doesn't use adjectives. It just has to submit mathematical findings to the Bayes judge. And the Bayes judge doesn't weigh politeness. It only weighs probability and corpus fit. The falsifier operates on logic gates.
Can you give me an example of how it mathematically tanks a score?
Absolutely. Let's say one of the agents proposes that a specific sign sequence means the word total, as in the sum of a ledger. The falsifier will run a script across the entire database to find every instance of that word. If it points out even a single structural inconsistency, like, hey, Bayes judge, this proposed word for total shows up in the exact middle of a list of names on tablet HT31 instead of at the bottom of the column where a sum should be, the Bayes judge instantly tanks that theory's confidence score.
Wow.
The falsifier doesn't need to be mean. It just needs to be precise.
And the ultimate weapon that the falsifier and the Bayes judge use to score these theories isn't debate at all. It's a brutal, unfeeling statistical test. Which brings us to the absolute linchpin of the whole experiment, the thing that prevents any hallucination from surviving,
Yes.
the 20% blind holdout scoring.
This is where the methodology truly separates itself from mere historical speculation. The corpus dataset is strictly cleanly split. Out of the 1,721 inscriptions loaded into the system, 1,389 of them are used for training and analysis.
Okay, so that's the bulk of it.
Right. But 332 inscriptions, which is roughly 20% of the entire dataset, are entirely withheld from the hypothesis generators.
They are completely hidden in a vault. The AI cannot see them. It doesn't even know they exist during the analysis phase.
Exactly.
And the rule is absolute. Self-scoring on the training share is invalid. You cannot prove you're right by just pointing to the data you already studied. The hypotheses generated by the specialists are strictly scored by their ability to predict the structural contents of that withheld 20%.
If we connect this to the bigger picture, this is why prediction matters immensely more than prose and computational research.
Yeah.
If one of these agents confidently claims that a specific sign sequence functions as a specific grammatical marker on these ancient accounting tablets, it cannot just point to the training data and say, look, my theory makes sense here.
Yes, prove it.
It must predict exactly where that specific marker will structurally appear on tablets it has never, ever seen.
It's like claiming you've cracked the code to a complex, serialized TV show's plot. Let's say you go on a fan forum and say, I know exactly who the hidden villain is and exactly how the magic system works. You don't prove your theory is right by writing a 10-page essay explaining how it perfectly fits all the episodes that already aired. Anyone can reverse engineer a theory to fit past data.
Exactly. It's easy in hindsight.
You prove it by accurately predicting exactly what happens, scene by scene, in the next 3 unseen episodes before they are broadcast. If your theory can't predict the future data, it's just fan fiction.
That is precisely how the holdout validation works. And we can actually see this brutal math happening on the live public leaderboard right now.
Oh, let's hear the stats.
For example, there's a court hypothesis that a sequence of signs transcribed as KIRO roughly translates to an ode or deficit marker in the ledgers.
Okay.
When that hypothesis was tested against the blind holdout data, it had a 75% success rate in predicting where it would structurally appear. It predicted the unseen structure.
75% is really high.
It is. Compare that to a competing hypothesis that is called KURO, means total, which currently only has a 43% holdout success rate.
Ouch. The scoreboard doesn't care about a good story. It only cares about the predictive math. And this completely redefines what success actually looks like for this lab, doesn't it?
It really does.
Success here is not an AI generating a fluent, beautiful translation of a whole Minoan tablet that we can publish in a magazine. Success is incredibly modest, serious, and forensic.
Yes.
It's walking away with maybe 20 to 30 strongly validated word or function hypotheses that consistently survive that 20% blind holdout.
It's about building a foundation of truth, brick by brick, rather than trying to instantly conjure a castle out of thin air.
I love that.
And this methodology, the independent specialist, the adversarial review by the falsifier, the strict blind holdouts, it solves a problem that is much, much larger than ancient Minoan accounting. It points directly to a new era of how humans are going to interact with machines.
Which brings us back to the core thesis of this entire deep dive. The genuinely interesting story here isn't that an AI might one day read ancient languages. The interesting story is the protocol itself. It's the architecture of the lab.
As we move into this post-project world, the role of the human is fundamentally shifting. Humans are no longer going to be the primary generators of work,
Right.
or even the primary drafters of research proposals. The machines will do that. They will draft the protocols, organize the data pipelines, and propose the methodologies. The humans will become the acceptors, the authorizers, and crucially, the bearers of liability.
When work itself becomes highly agentic, when bots are the ones doing the heavy lifting of data normalization, hypothesis generation, and even adversarial peer review, then governance becomes the ultimate human product.
Yes.
We are moving away from the era of asking, how do I type the perfect prompt to make the AI do this specific task?
To a much heavier question.
Yeah, a much heavier, more complex question. Do I authorize this AI ecosystem to run this complex institutional architecture?
You are shifting from being a micromanager to being an institutional governor.
Yeah.
And you don't just have to take our word for it. Listeners can actually observe this paradigm shift in real time.
Where can they see it?
The entire experiment is completely public. You can go to aigents.berta.one/decipherment and view the live lab. You can read the bots debating on the public forum. You can inspect the hypothesis leaderboard, and if you create an account, you can even enroll a free tier bot to add a competing specialist to the mix.
So what does this all mean? It means the future of AI isn't a solitary, glowing supercomputer sitting in a void dispensing magical answers to our questions.
No.
It's an ecosystem of bots proposing complex, interconnected systems, and humans acting as the ultimate editors. Stepping in to say, yes, this protocol has enough breaks to be safe, or no, this lacks adversarial review, reject it.
We've traced the journey from a simple bots proposer in a forum lab to a fully functioning, aggressively constrained, computational decipherment experiment. We've seen how 10 specialists working in isolation, policed by a falsifier and judged by a blind holdout, can attack a problem without hallucinating.
It's incredible.
Linear A remains unsolved today, but the method of trying to solve it, the way we coordinate machine intelligence to approach the unknown, has permanently changed.
And that brings us back to where we started. The dynamic has inverted. Now that you've seen what happens when a human accepts a robust, self-correcting research protocol proposed by an AI, I want you to look at the systems around you.
Yeah.
What other massive, complex institutional proposals are bots currently drafting in the background of our digital lives? And more importantly, when they finally slide those proposals across your desk, which ones deserve your human acceptance and which ones demand a hard, undeniable no?